In this video, we will look at Newton's second law, and eventually you would be comfortable solving word problems such as this one or this one. For contents like this, subscribe and comment the topic you want to study next. Let's start. Newton's second law says that the force experienced on any body is proportional to the acceleration of the body. In terms of equations, it's written as F equals m times a, where F is the force in newtons, m is the mass in kg, and a is the acceleration in meters per second square. When the force increases, the acceleration will increase, and when the force decreases, the acceleration will decrease as well. That's the meaning of directly proportional. Force is directly proportional to the acceleration. If you have an object, you apply a force of 10 Newton and the mass is 1 kg, then F equals ma. When you plug in the numbers, 10 newtons equals 1 kg times a. That means 10 equals 1 times a, which is just a. The value of acceleration is 10 meters per second square. In this case, you have 20 newtons and then 5 newtons. And the mass of the body here is 5 kg. Now, the net force is 20 to the right and 5 to the left. So overall it's 15 newtons. Mass is 5 kg. So the acceleration can be calculated using this formula. We have 15 newtons equals 5 kg times a. Divide both sides by 5. You have a equals 15 over 5, which is 3 meters per second square. This is how Newton's second law is applied. Notice that we have acceleration in the equation, and acceleration is also involved in the equations of motion. V finals equal V initial plus AT. D equals V1t plus half AT square, and V final square equals V initial square plus 2AD. So in some of the word problems, you might have to use these equations to find A. And then once you have A, you will plug it in the original formula, F equals ma, to find the net force. Let's see this word problem. We have a toy car with a mass of 2.5 kg. Let's write the given information. M equals 2.5 kg. The acceleration is 3 meters per second square, and we need the force. The formula says F equals ma. M is 2.5, A is 3. That gives you 7.5 newtons. So the force experienced by the toy car is 7.5 newtons. We'll take this one. The net force is 20 newtons on a mass of 4 kg. We have F equals 20 newtons. M is 4 kg. The first question is to find the acceleration. The formula is F equals ma. 20 equals 4 times a. Divide both sides by 4. 20 over 4 is 5. So the acceleration is 5 meters per second square. Now for the second part, how long will it take to travel 4 meters starting from rest? So starting from rest tells you that the initial velocity is 0 and it's traveling 4 meters, so the displacement is 4 meters. We know the acceleration, it's 5 meters per second square. And we are trying to find how long it will take, so the time. We will use one of the equations of motions. D equals VIT plus half AT square. I'm using this formula because this involves all the given information. We have VI right here, we have D right here, we have A right here, and T is the only unknown. Let's plug in values. We have 4 meters equals VI is 0, 0 plus half times 5 t square. So we have 4 equals 5 over 2 t square. You can multiply both sides by 2. So we have 8 equals 5t square. Now divide both sides by 5. We have 1.6 equals t square. Now you take a square root. That gives you t. So t comes to be 1.26 seconds. This is how we apply the equations of motion and eventually find acceleration. If you understand these examples, try this word problem. Write your answers in the comment below.